Imagine the worst day in Earth's history. The day the sky caught fire and oceans boiled. 66 million years ago, an ordinary morning became humanity's origin story in the most unexpected, violent way. Dinosaurs had ruled for 160 million years, apex predators commanding every ecosystem from pole to pole. Then, in a single heartbeat, everything changed as a mountain-sized rock traveling 45,000 miles per hour struck. The impact released energy equivalent to 10 billion atomic bombs detonating simultaneously across the planet's surface. Within minutes, the Cretaceous world began dying in ways so horrific they defy imagination completely. Forests ignited globally, tsunamis taller than skyscrapers scoured continents, and darkness swallowed the sun for years. This wasn't just extinction, it was planetary apocalypse, the cosmic lottery that cleared the stage for us. Welcome to the last day of the dinosaur age. The final morning. The late Cretaceous morning began like countless others across millions of years of evolutionary stability. Pterosaurs glided on thermal currents rising from sun-warmed plains, their shadows dancing across herds below. Mosasaurs patrolled shallow seas, ambushing fish and ammonites with ruthless efficiency in crystal waters. Tyrannosaurus rex stalked through forests that had never known anything but dinosaur dominance for eons. The planet had settled into ecological rhythms refined over geological timescales, perfectly balanced and seemingly eternal. Flowering plants carpeted the landscape in colors dinosaurs' ancestors could never have imagined when they began. The continents had drifted into configurations somewhat recognizable to modern eyes, though still dramatically different. North and South America remained separated by ocean, while Europe consisted of scattered island chains. Nothing in this stable world suggested that within hours, 75% of all species would begin dying. The Yucatan Peninsula, a shallow tropical sea teeming with life, would become ground zero for catastrophe. 6 miles above the atmosphere, invisible and undetectable, a rock 10 kilometers wide plummeted toward collision. This asteroid had journeyed through space for eons, its trajectory calculated by gravity and momentum alone. The laws of physics ordained that two objects, Earth and asteroid, would occupy the same space. When they did, the kinetic energy of that collision exceeded all volcanic eruptions in history combined. In an instant measured in microseconds, the Cretaceous world began its violent transformation into something unrecognizable. Impact and Inferno. The asteroid struck the shallow sea near modern Mexico's Yucatan Peninsula with incomprehensible force and violence. In less than a second, it vaporized itself along with cubic kilometers of rock and water. The impact excavated a crater more than 110 miles in diameter, a wound that still scars. The Chicxulub crater, named for the nearby town, tells the story of that moment written in stone. The shockwave radiated outward at supersonic speed, flattening everything for hundreds of miles in all directions. Trees that had stood for centuries disintegrated into splinters, while any animal caught above ground simply ceased. But the immediate destruction around the impact site represented only the opening act of global catastrophe. Trillions of tons of vaporized rock and water blasted upward through the atmosphere into space. This ejected material, superheated to incandescence, arced through the upper atmosphere before beginning its descent back. Geologists worldwide have discovered a thin layer containing tiny spherules of once molten rock and sediments. These glass beads mark the exact boundary between the Cretaceous period and everything that followed. Each spherule became a miniature meteor as it plummeted back through the atmosphere 40 minutes later. The friction of their descent transformed the entire upper atmosphere into a radiant heat source. For several hours, the sky glowed red-hot across the entire planet as billions of incandescent. Infrared radiation bathed the Earth's surface with intensity comparable to standing inside an industrial furnace. Any animal not underground or submerged in water faced temperatures exceeding several hundred degrees in minutes. Dried vegetation ignited spontaneously across continents, triggering wildfires that merged into continental conflagrations within hours. Flying creatures had nowhere to escape as the atmosphere itself became a weapon of destruction. The heat pulse alone may have killed the majority of terrestrial dinosaurs before any other. In just a few hours, evolutionary lineages stretching back 160 million years were effectively terminated. the mega tsunami. Even as the atmosphere burned, another catastrophe unfolded across Earth's interconnected oceans and distant coastlines. The asteroid's impact displaced an incomprehensible volume of water, creating the largest tsunami in history. Computer simulations reconstructing that moment reveal a wave initially towering nearly 3 miles high. For perspective, that's taller than Mount Rainier, a wall of water visible from hundreds of miles. The mega tsunami radiated outward from the impact site at speeds exceeding 500 miles per hour. Within the first hour, coastlines around the Gulf of Mexico experienced waves hundreds of feet tall. The geological record preserves the chaos. Ocean sediments mixed with land fossils, marine sand deposited. These jumbled layers form a distinct boundary, marking where the Cretaceous ended and the Paleogene began. But the destruction extended far beyond the immediate impact region as the waves propagated globally. In what is now Argentina, thousands of miles from ground zero, the shockwave triggered earthquakes and landslides. These secondary disasters generated their own local tsunamis, compounding the devastation across multiple continents simultaneously. The interconnected nature of Earth's oceans meant nowhere remained safe from the water's wrath. Recent studies estimate this tsunami carried 30,000 times more energy than the devastating 2004 Indian Ocean. That modern disaster claimed over 230,000 lives. The Chicxulub tsunami destroyed entire ecosystems across hemispheres. Coastal marine environments that had thrived for millions of years were scoured down to bedrock. The wave penetrated hundreds of miles inland in low-lying regions, drowning forests and plains alike. As the tsunami traveled, it stirred oceanic sediments halfway around the world with its energy. The seabed shows evidence of this disturbance. Stratified layers accumulated over millions of years were. Older sediments were deposited atop younger ones, creating geological chaos that still puzzles researchers studying. This mixing didn't just rearrange rocks, it fundamentally disrupted marine ecosystems from surface to seafloor. The darkening sky. Survivors of the heat pulse and tsunami faced an even more insidious threat materializing overhead. The impact had injected approximately 2,000 gigatons of pulverized rock into the upper atmosphere. To put that in perspective, imagine the mass of Mount Everest multiplied by 11. This dust cloud encircled the planet within days, blocking sunlight with unprecedented efficiency and global reach. Darkness descended across the world, transforming day into perpetual twilight that would last 15 years. Temperatures plummeted as the greenhouse effect reversed, with solar radiation unable to penetrate the dust. In some regions, average temperatures dropped by 25 degrees Celsius within months of the impact. The rapid cooling disrupted weather patterns that had remained relatively stable for millions of years previously. This impact winter proved more deadly than the immediate catastrophe for most surviving species worldwide. Plants require sunlight for photosynthesis, the fundamental process powering nearly all terrestrial food chains. Without light, vegetation began dying en masse across every continent, creating cascading ecological collapse. Herbivorous dinosaurs, even those that survived the initial impact, faced slow starvation as their food disappeared. The extinction of herbivores doomed the predators that depended on them for survival and sustenance. Tyrannosaurus rex and other apex predators outlasted their prey by only weeks or months. The fossil record shows their bones lying in sediments just above the impact layer. Marine ecosystems collapsed simultaneously as phytoplankton, the ocean's primary producers, died without sunlight reaching the depths. Sophisticated climate modeling reveals that dust contributed 75% of atmospheric material blocking sunlight initially. Sulfur from vaporized rock comprised 24%, while soot from global wildfires added merely. Together, these particles created conditions resembling nuclear winter, a term coined for similar scenarios. High latitudes experienced the most extreme effects with prolonged snow and ice cover spreading. The survivors world. Not all life perished during those horrific first hours, weeks, and years following impact. Approximately 25% of species survived, though likely with populations decimated to near total mortality. The survivors shared certain characteristics that proved crucial during the darkest period of Earth's history. Small body size, burrowing behavior, and ability to survive on limited resources marked successful lineages. Mammals, then mostly small, rat-sized creatures, possessed adaptations perfectly suited for the post-impact environment. Their underground burrows provided insulation from the initial heat pulse and subsequent freezing temperatures. They could survive on seeds, roots, and carrion when fresh vegetation became unavailable entirely. Their warm-blooded physiology allowed activity even as ectothermic reptiles grew lethargic in the cold. Freshwater ecosystems fared somewhat better than terrestrial or marine environments during the immediate aftermath. Rivers and lakes provided refuges where aquatic life could persist with less direct exposure. Crocodilians, turtles, and various fish species survived in these protected environments, waiting for recovery. Their cold-blooded metabolism meant they required fewer calories than warm-blooded dinosaurs of similar size. Birds, technically flying dinosaurs, survived through a combination of factors that remain partially mysterious to researchers. Some species likely possessed seed-eating adaptations, allowing them to exploit resources unavailable to other animals. Their flight capability may have enabled long-distance travel to less affected regions during the crisis. Whatever the reasons, certain bird lineages persisted and eventually diversified into 10,000 modern species. The recovery period began slowly as dust finally settled after 15 years of darkness. Sunlight returned gradually, allowing hardy plant species to recolonize barren landscapes across the continents. But the climate remained unstable for thousands of years as carbon dioxide from wildfires. This created a greenhouse effect that rapidly warmed the planet, swinging temperatures wildly again. Species already stressed by the long winter now faced opposite extreme conditions suddenly and unpredictably. Geological evidence. Modern scientists reconstruct this ancient catastrophe through multiple lines of geological and paleontological evidence worldwide. The most obvious marker is a thin clay layer found in rock formations globally. This boundary layer, rarely more than a few centimeters thick, separates Cretaceous fossils from Paleogene fossils. Above it, dinosaur remains simply vanish from the fossil record with striking finality and completeness. Chemical analysis of this boundary layer reveals elevated concentrations of iridium, an element rare on Earth. Iridium is abundant in asteroids, providing smoking gun evidence of extraterrestrial impact as the extinction cause. The discovery of this iridium anomaly in the 1980s revolutionized understanding of mass extinctions. It confirmed that cosmic impacts could and did reshape life's history on catastrophic scales. The Chicxulub crater itself remained hidden for decades, buried beneath younger sediments and ocean waters. Geophysical surveys eventually revealed the structure's distinctive circular pattern and shock-metamorphosed rocks indicative of impact. Drilling projects have recovered core samples from the crater, providing direct physical evidence of vaporization. These samples show glass formed from instantly melted rock alongside fragments of the impactor itself. Tsunami deposits across multiple continents provide additional evidence of the mega wave's global reach. In places like Texas and New Jersey, geologists find jumbled layers mixing marine and terrestrial. These chaotic sediments tell stories of incomprehensible violence as water and debris scoured landscapes. The deposits contain shocked quartz, mineral grains showing microscopic fractures only producible under extreme pressure conditions. The legacy. The Chicxulub impact fundamentally reset Earth's evolutionary trajectory, creating opportunities that would eventually lead to us. With dinosaurs eliminated, mammals rapidly diversified into ecological niches that have been closed for millennia. Within 10 million years, a geological eye blink, mammals evolved from rat-sized survivors into creatures dominating. Primates emerged during this explosive radiation, eventually giving rise to hominids and modern humans specifically. Understanding this extinction event provides crucial insights into planetary vulnerability and the fragility of ecosystems. The interconnectedness of Earth systems meant a single impact triggered cascading failures across atmospheric. This knowledge informs modern concerns about rapid environmental change and ecosystem collapse under stress. The dinosaurs' extinction reminds us that even dominant, successful life forms remain vulnerable to catastrophe. The study of the Chicxulub impact has also catalyzed planetary defense initiatives monitoring near-Earth objects. While impacts of this magnitude occur only once every 100 million years statistically, their consequences, Modern tracking systems identify potentially hazardous asteroids decades before possible impact, providing time for intervention. This represents humanity using knowledge of ancient catastrophe to prevent future ones from occurring. The day the dinosaurs died was the worst and best day in Earth's history simultaneously. Terrible beyond comprehension, yet necessary for our eventual existence and evolutionary emergence from small mammals. Those dinosaurs ruled magnificently for eons, perfectly adapted to their world until the world changed. In their absence, our ancestors, frightened, hungry, but alive, inherited a devastated planet that slowly healed. Today, we study that ancient catastrophe with tools those survivors could never imagine or comprehend fully. Perhaps the real lesson isn't about asteroids or extinction, but about resilience, adaptation, and life's determination. Even when the sky burns and darkness falls, something always survives to begin again.